My name is Jad Yamin, and I'm part of the Google Developer Student Clubs. And I'm here today with you to brainstorm and try to solve the lab concerning scikit-learn model serving with online prediction using the AI platform on Google Cloud. So before we get started, I'll make sure to include a link to that showcases how you get this monthly subscription on your QuickLab account since you are part of the GDSC. Without further ado, let's get started. So I click on start this lab. I'm not a robot. Okay, the image scores. Great. Okay, so I'll put here that I need to use my subscription. Okay, it's fine. Let's restart. Okay. Let's just wait some couple of minutes and then we'll get started. I think when you do that on your own machine locally, I don't think you'll run through these kind of issues, but since it's there, well, we might wait for it. Okay, so I'll present the table of content for today's session. So we'll go we will go through the representation of our workflow. We will train a model using scikit-learn that predicts whether someone has an income more than 50K per year or not. Then we will save our model, then train it, and then deploy it on the AI platform. Okay, so the lab has started. Okay, so as I can see here, 2 minutes had elapsed. Anyway, so what we will do here is copy the link, open an incognito tab, paste it. Okay, so we need to copy this, the username. It's temporary access to Google Cloud for free. We need to paste it here. Great. Okay, I'm sorry. Okay, what happened? Let's restart. It's fine. Okay. Okay, perfect. Then we need to copy the password and paste it here. Okay, let's try copying it this way. Paste, and there you go. I need to accept these terms, and there we have it. We have the exclusive access to Google Cloud. Okay, so we will be using this project ID to specify the bucket's name. I agree. I don't want to receive email updates since it's not my account. Okay, and there we have it. We have access to Google Cloud. Okay, so as before mentioned, we will be building a model with scikit-learn, and we need to host it on the cloud or on a server to be able to make it at the disposal of everybody, so everybody can use our model. We will use the AI platform. We will use as well some cloud storage to be able store our model. Okay, perfect. Okay, so here they broke down our workflow into 5 steps. First of all, we need to create and save the model. We will go through these steps deeply. Don't worry about them for the moment. We need to upload our saved model to a cloud storage, to a cloud bucket, and then we need to create or allocate some resources for the model in AI platform. We need to specify the version because AI platform manages the versioning of our model, and you can think about AI platform just like Docker or any other containerization tool. Okay, and then we will make an online prediction based on our test set. So this is the representation of this lab. So we have the model here. We have the Google Cloud Platform that manages the communication between the trained model and other applications. Okay, so let's get started. Okay, so as before mentioned, we will be using Google Cloud, the AI platform prediction, Google Storage, and Google Cloud SDK. Okay, so there are some definition about Google Cloud. What is Google Cloud? What is the AI platform prediction? It's a managed service that enables you to easily build machine learning models that work with any type of data and any size. We will define the data preprocessing pipeline using Python, and we will see how this is accomplished later on. Okay, so the setups and requirements, we've already gone through the steps about the account, logging in, etc. Okay, here we have the Google Cloud Console. So this is a step that is optional. It's just for testing the shell if we have access to the Cloud Shell or not. Let me test this real quick. Okay, so they need us to run this command, and as they defined it, gcloud is the command line tool for Google Cloud. It comes pre-installed on C and supports tab completion. So I think this C is a corrupt word or missing word, but anyway. So gcloud is the command line tool to manage everything that is related to Google Cloud without using the graphical user interface. So we need to test that we have access to the Cloud Shell. So let me test this real quick. I just press here to activate the Cloud Shell. It might take some moment. Alright, connecting. It's a pretty intuitive interface to use. Here we can see all our CPU usage in the compute engine. I don't want to go through all the services that Google Cloud offers, but I think we might see them in other sessions later on. Okay, so I need to test gcloud authentication list. Okay, authorize. Perfect. This is my account. So I have access to the Cloud Shell. Okay, let's continue. These are basic setups. Okay, so what we need to do is to create a storage bucket. You know, the cloud storage is usually called or it's referred to as bucket. So it's the normal storage. It's just think of it like Drive or so. You just can create your own storage and upload whatever file you want. So okay, there's a convention here that each bucket should have a unique name. Uh, like I can't have the same cloud bucket name as yours. Okay, this should be different. It should be a unique name. So we will be using the GCP project ID since it's unique. Okay, and this uniqueness helps GCP to have a good reference to the create bucket. But we don't need to stress about the reason. Let's just choose a unique name. Okay, so I'll go here real quick. I'm sorry, storage, cloud storage. Let's browse. Okay, I have no buckets. Let's create a bucket. All right. Okay, so this is my okay, I'm sorry, I didn't copy this. Let's copy it, paste here, pick a globally unique permanent name. Okay, continue. Okay, so they want the location set to US Central 1 Loa. So let's set it real quick. I'm sorry, it's the region US Central 1 Loa. Continue. I think they need the standard one. Set L type to region, make sure. Okay, then create. Perfect. We don't have to configure anything else. Okay. Create a cloud bucket quick-labs-gcp-00. Okay, so here we have the platform for our bucket. Got it. I can just upload anything I want here. Okay, just like Drive. And of course, I can manage some permissions. I can manage the permissions for a certain let's say file or object. This field can be edited, of course. So yeah, let's check my progress real quick. Check that I have the points. Okay, it's checking for my bucket. And the okay, so I got 10 points here, so it's validated. Perfect. This will take some time to load, and then I can see the green tick. I'm sorry for the inconvenience on QuickLabs today, but be sure that it will be fixed real quick. Okay, if not, just reach out to the support. They have a live chat. I'll showcase how to do that in another video. Okay, so for the time being, I need to create a virtual machine on the cloud. It needs to be a compute instance that I can manage through SSH. Here are some okay, so there are two different ways to create a compute engine virtual machine. The first way is by using the command line here, the cloud shell. As mentioned before, we can just manage the cloud using the cloud shell. And the other method is just by using the graphical user interface, by going here, compute engine, virtual machine instances, and create a virtual machine instance. Okay, but for the for demonstration purposes of the lab, I'll just use the cloud shell. Okay, so here we have a virtual machine that is already set up when we started the lab, because we will use it later. So I can click here on create instance, or I can just activate my cloud shell and copy this and paste it on the cloud shell. And as you can see here, we need the image to be Debian 8. These are the configurations, the service account, I won't stress about it. Okay, so some configurations about the storage, etc. The zone for the virtual machine, and some tags. We will use this virtual machine as server later on. So without further ado, let's paste this. It will create my virtual machine. Let's just wait for it. And as I mentioned before, Google Cloud is really intuitive to use. I use it in my projects at work, at the university, etc. Okay, perfect. So this is the name of my virtual machine. I've named it here. As you can see, Scikit learn-vm. This is the name, this is the zone, this is the type. Since I've configured it with Debian, etc., this is the type of my virtual machine, and this is the some information about the IP address, and the status is running. If I refresh here real quick, okay, I could have refreshed the virtual machine, but it's fine. So yeah, I should see my virtual machine in here. Okay, here is it, Scikit-VM. So let's continue, check my progress. Okay, I got 30 points, 10, 20. So now I need to SSH to the virtual machine. If you're not familiar with SSH, it stands for Secure Shell. It gives us some access to the virtual machine in I'd call it non-GUI mode. Okay, it's only the terminal. So yeah, this tool needs to create the directory, etc. Yes, I need to continue. Okay. I didn't enter any paraphrase. So yeah, here we have it. We have access to the machine. Let's say I can run the basic commands, ls it doesn't contain anything, etc. So I need to do some installations. I need to install pip and virtual env. It's for creating a virtual environment, so that all the requirements of the Python packages, etc., are I'd say encapsulated within the virtual environment, so that you won't pollute your operating system with many packages, versions, etc. So all I need to do is update the packages on Debian and install Python 3 pip, and then install virtual env. So let's do this real quick. Perfect. It's installing. Okay, sudo apt-get install -y. It's for telling the command yes when it asks. Python 3-pip. Perfect. It's installing. And then I need to install virtual env. Okay, so as you can see, it's installing. Okay, so let's check real quick what is it required after the after installing virtual env. So I need to create a virtual environment, create an isolated Python environment, as we mentioned before, and then we need to activate this virtual environment. When we create it, we've named it ml-env, and we've selected that the Python version needs to be 3.5, and then this directory is created, and then we need to enter the command source and pass this directory to it, ml-env-bin, and in this directory there's the executable activate to activate the virtual environment. So yes, let's check the progress real quick. Good. installed pip. Let's install virtual env. Done. Let's set up our virtual env with the Python version 3.5. Okay. After that, let's do the let's activate the virtual environment. Okay, as you can see here, it's activated. And by the way, I'm sorry for going real fast through these steps, but they are just straightforward. I'm trying my best to explain each step I'm doing. But we need to spare the time to dive deeply in the model and the Python code, etc. So let's install all the libraries that I'll be needing. Google API, Python client, Scikit-learn, of course, pandas to manipulate the data frames, etc., SciPy and NumPy, and I need to upgrade the client to the latest version. So let's do this. Perfect. It's installing. Let's check the progress real quick. So here I download the dataset. Okay, great. So we are here. A minute away from the technical machine learning talk. These are just some setups. Okay, perfect. Let me see. Okay. Okay, so here we need to set up some environment variables so that each time I need to get back, let's say I need the project ID, and I don't want to copy it from here each time, so I can just set it up as an environment variable. I'll do this line by line because I need to replace this your project ID by my real project ID. Let's erase this. Equals, where's my project ID? This one. Let's copy it. Perfect. I need my bucket ID here. How to check my bucket ID? We can do this real quick. I think I specified the project ID as the name of the bucket, but let's double check. Okay, the buckets are loading. Okay, I'm sorry. Okay, perfect, that's it. I'm sorry. Okay, so I can copy this from here. Copied, paste. Ooh. Okay, so let's copy it from there. Great. Next, we will give a name for our model. We will call it census, since it's the name of the dataset. The dataset talks about the distribution of people based on gender, age, and some other features. And we need to use this dataset to predict if a certain person has an income higher than $50,000 per year or not. So yeah, let's export a version name, because as before mentioned, the AI platform can be used as or has the feature of versioning for our model. So we will specify that the version name is 1. v1, and then we will need to specify our region, and this is the region of where the model will be deployed. Okay, perfect. They need input data file, include a JSON file that contains the data used as input models predict. Form 1 and foresee the complete guide. This is not a step that we will be doing right now. Okay, so let's download the dataset. Let's make a directory called census data, mkdir census_data. Let's check if it's created using ls. Great, we have our ML environment and the census data. Okay, so I need to download the dataset for this lab. Curl is used to if you want to do some let's say GET request or POST request, some HTTP requests in general, using the command line. You can use the command line tool called curl. It's just like if you need to go to the browser and copy this link and download, etc. You don't have to do all these steps. Just use curl. And curl can be used as well to test your API, just like Postman. But I don't want to dive into details for now because it will be outside the scope of our session. It's not an API session. So yeah, we will download the adult.data. It's for the training test, training set, and then the .test for the test set, and dash in output. The downloaded files will be added in the census_data that we've created right now, adult data and test. Okay, so let's begin with this. Okay, it's downloaded. Let's download our test set as well. Perfect. This Kreml says that this dataset is provided by a third party, so Google provides no representation warranty or guarantees. So as I described the census data, okay, we can check here the documentation real quick. Let's check my progress. Okay, so the characteristics are multivariate. We have some categorical data types, some numerical data types. You can think of it as categories and integers. The task we need this data set to solve is a classification problem. We need to classify whether the income exceeds $50,000 a year or not. So yeah, here are some informations about the dataset, and you can of course download it on your own machine. So okay, we have the progress here. So let's get started with the first module. We need to train the model and save this model, load the data into a pandas data frame, and we need to use an XGBoost for the model called XGBoost okay, we need to fit it on our data set to be able to solve our classification problem. Next, so yeah, we need the scikit-learn model, etc. I don't want to read all of this. Just follow the video, and you'll have all the everything you need to be able to solve this lab. So okay, let's get started. We need to create a new file called train.py. We will use Nano as a text editor. Of course, you can use any text editor you want. since we are using the Cloud Shell, it's easier to use Nano, at least from my end. So Nano, train.py, we need to import everything that we will be needing. Pandas, the random forest for classifying, joblib, kbest, feature union to be able to unite two features, two columns, let's say. And the pipeline is to set up the pipeline that first of all I need to pre-process my data and then feed it to the classifier. You don't have to understand all these imports for now. We will dive into them soon. So let's copy this. Perfect, paste. Okay. Now we need to define the format of our input data and the unused columns. So these are the columns from the census data files, and these are the columns that needs to be turned into numerical values. I don't think I don't know if any of you has taken the session about data science, but real quick, categorical data are data of types. Let's take, for example, the sex. It's male or female. So the computer can't understand male or female. So what we need to do here is, let's say, one hot encode this column. One hot encoding is to convert the sex column into two columns, one called male and one called female. And if the sex is male, the male column will have a value 1 and the female will have 0. And if the sex is female, then the male column will have a value 0 and the female will have a value 1. Okay, it's just because the computer can't understand the categorical columns. This is a way of representing the categorical variables. Another way is, let's say we have categories about the temperature, let's say, or the grades. Let's say the grades, with a condition that the grades are not continuous. Let's say we have grades 10, 20, 30, 40, 50, 60, 70, 80, and 90, and 100. They are quantified. So one way to encode these numbers, or not, these are okay. So they are already okay. So I don't. So yeah, another way is to encode them using label encoding. So we encode them by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, for example. And we only use label encoding if we need, if our categorical data can be compared to each other or not. Okay, like the computer will understand that 2 is better than 1, etc. But don't stress about this if you didn't take the data science session. There are a lot of resources here on Quick Labs. You can take them, and you'll find this very easy. So yeah, let's define the unused columns and the columns that we will be using to decide if the income exceeds 50K or not. Okay, perfect. What else? Okay, so here we need to open our data set and put okay, so we open the file as train data. Now we need to read this file and put it into a data frame. We will call it raw training data, and then remove the column we are trying to predict. Yeah, but just a quick notice here that pd.read_csv its output is the is a data frame. Okay. I don't want to repeat that, since it's a session about advanced ML, and I think every one of you are familiar with these terms. But if I repeat such things, the level of understanding and the reach of people that can take this lab would be greater. So yeah, without further ado, remove the column we are trying to predict. We need to predict the income level, so we've isolated this, and all of the other columns are taken as features, which means as columns that we will use, or the model will use, to decide the income level. So now we need to create a label list, because as you know, the income levels are the income levels are not in a way they aren't the values of income level column are not true and false, right? But the problem we were trying to solve is a classification problem. Okay, so we need to decide if it's in this class or that class. So what we need to do here is to convert the column income data to two columns if it's greater than 50k or not. So here we have our converted labels, and then we need to do the same thing for the test set. Okay, we've done some stuff for the training set, some pre-processing, isolating the labels and the features, and we need to do the same thing for the test set. Okay, let me copy this, paste it here. Okay, so add the following, okay, etc. Okay, so here we need to set up a pipeline. The pipeline will tell okay, so we will tell when we run this Python code, we will set up a pipeline in a way that when the data flows in let's say the code, it won't directly get into the model. It's not how things work. It's not a good practice, because we need to take care of transforming the categorical variable, for example, and set things up in a way that the model can read the data that we've had as input. So okay, here we mentioned that we need to convert the categorical feature into numerical ones. We had two ways, and here they are saying that we will use the random forest classifier. And by the way, the random forest classifier and the and XGBoost are a bit close to each other. Okay, so don't worry about these terminologies. Okay, so each category column needs to be extracted. So select best and label binarizer. It's to convert the categorical values into numerical ones. I don't use these. I use a class from Scikit that is called one-hot encoder. Okay, but it's around the same. Okay, it's the same concept about converting categorical values into numerical ones. We have a scores array. We will see that later in the code. So yeah, so first of all we need to loop on the columns. -1, it's because the last column is for the income level, and then in these, if the column is a categorical column, okay, so here enumerate is the index comma the column. If the column is categorical, so if it's in this list, then let's continue in the code. Then we will create a scores array to get individual categorical column. Example, if this is a sample from our data set, as we can see here, the state is a categorical variable. So at the output we will have state. Okay, so we are just trying to extract the categorical columns, to pre-process them, to convert them into numerical, and then we will combine them to the others. Okay, so we need to isolate them at the first step, pre-process them, and then recombine them in our data set for training purposes. So the score is empty. For j in range, the length of this array. If I, the index here, is equal to j, that means the column is the categorical column we want to extract. So scores.append 1. Okay, so we will have a 1 here. Scores was empty, we will have a 1. If it's not, we will append a 0. Okay, when all this for loop is done, we will have the scores matrix, and then we will start pre-processing the scores matrix. Select kbast, and then we will pass it to our label binarizer, and then we will fit the label binarizer on the training features. Here we've transformed the categorical column into numerical ones. Okay, and then we need to create a pipeline to extract the categorical feature. This pipeline is just doing the same as we've done before. We need to specify this is which categorical variable based on the I here on the index, and then we will pass the pipeline object and fit the select kbast and so yeah, we will compute the scores matrix with skb, and then fit the and then include the label binarizer. So yes, here we have it. Create a pipeline that extract the numerical features. So yes, we need to extract okay, from the columns use the feature that are numerical. So yes, here we've done the very same thing, but instead of taking the categorical instead of encoding 1 to the categorical variable, we are doing this to the numerical ones. Okay, I'm sorry, we are doing this to the categorical ones as well. Okay, so here we need to add to the categorical pipeline a key, it's tuples. We need to add the a field called that we will call numerical, and then the select kbast in it, and then we need to unify all our features by okay, so yeah, combining all the features that were present in the categorical pipeline after preprocessing. So yeah, the numerical so let's wrap it up quickly. So the numerical variables are still the same. However, the categorical variable are converted to numerical variables and then combined with the non-touched, I'd say, numerical features. Okay, so think of it that way. We have isolated at a first step. We have isolated our categorical variable. At a second step, we pre-processed them and converted them into a numerical feature. The third step is combining these isolated categorical variables with the isolated numerical variables. Okay, so we will have back our full data set. I'm sorry for the background noise. So this is a trade-off, of course. The model is very simple, but yeah, the main here disadvantage, of course, in every data science project, is that you need to pre-process your data before feeding it to the model. And finally, we need to create our classifier. We will be using random forest. We have our pipeline. Our pipeline is the okay. We need to pass the pre-process function, and then okay. I'm sorry. Okay, and then we will okay. So let me show you real quick. Okay, I'm sorry about that. Okay, so here in our pipeline we have defined the okay, we have okay, so pre-process is the union of all of the categorical features and the numerical features. The categorical features, of course, after they are pre-processed and converted into numerical ones, and the non-touched numerical ones. This is the pre-process. It means our pre-processed data set. Okay, so here we have defined another pipeline, which at a first step applies the or instantiates the pre-process, the feature union object that combines all the features, and then we will fit the classifier. Okay, so this is the pipeline. Okay, we have here fit our model. So we have okay, so we have the feature union, we have our classifier, we have fit our classifier to the training feature preprocess.transform train features. We have transformed the train features, the columns, by using preprocess. And here are the labels. The labels are the income levels. So we have fit our classifier and we pass it to the pipeline here. We pass both the classifier, which is a random forest classifier object, and the preprocess, which is a feature union object. So yeah, and now we will dump this pipeline in a joblib format. Okay, so we have exported our model because we needed to save it. So let me copy this and paste it here. I'm sorry for the theoretical talks, but I found that they are required to be able to proceed. So here is the completed file. Okay, very good. Now I need to save this file. Exit, yes. Okay. And now I need to run the train.py. Cool. And of course, by the way, you can here do whatever model you like. Okay. But just for this quick lab and for the lab purposes and the points, you need we need to do the exact same model. However, if you have a project for you to do, a personal project, just go ahead and do whatever model you like and whatever pipeline or pre-processing pipeline you'd like to do. Okay, so what we have here, we have preprocess is not defined. Oh, I think I've missed something. I missed to copy something. It's fine. I have the whole file train.py. Let me copy it here. This is the complete file. And paste. Perfect. Save it. And let's run again. Perfect. The model seems to be training. This deprecation warning, we don't have to worry about it. Model trained and saved. Perfect. ls, we have our model here. Now we need to deploy this model to be to make it at the disposal of everybody. If you get deprecation warning related to the NumPy model, please ignore it and move forward. Okay, so now what we need to do is okay, so we need to upload our model to the cloud storage. We have here the model.joblib that we've just saved, and we have here the model path that we've defined earlier. Okay, so let me check something real quick. Why are you having trouble here? Okay. Let me check it on the real quick here. echo $model underscore path. Okay, so here you can see the address of the cloud bucket I've created. Okay, so here we need to upload our model.joblib from the current directory to the cloud bucket that we've created. Perfect. This is done by using gsutil. It's just for managing. Okay, just remember this, that okay, nothing. Never mind. Copying the file, it's copied to my bucket. I can browse here the bucket and see that it's copied. Check my progress. I have 28 minutes left. 70. Create a model resource. So yeah, I need now to create. Okay, so now I need to create a resource, or let's say I'd call it a container on the AI platform to be able to host my model. Okay, so I have the $model name. It's where I've just uploaded my saved model on the Google Cloud bucket. Okay, so because AI platform communicates with the cloud storage, okay, not with the virtual machine I've created or I'm manipulating through SSH. We can do that, but it's more convenient this way. We've uploaded here our model. Okay, so to be honest, I don't care about the access, if it's public or not. You can share file to your friends and make things public, of course. So gcloud AI platform models, I need to create the $model name, which is here, and the region will be US Central, as I defined as well in my environment variables. Created the AI platform model. Great. Check my progress. Okay, now I need to set things up for my first version, I'd say, of the model. So I can do that by using this command. Okay, so I've set up. I've told that. Okay, so I need to create a version of our model. $version name, it was v1. It was defined as v1. The model name is the I think we've called it census. The model path is the path here on the bucket. The runtime version 1.14. The framework we've used is scikit-learn. The Python version is 3.5, as we have set up the virtual machine or our environment, our virtual environment here, and the region, of course. Okay, so this is creating a version of our model. Okay, so as you can see, our model here is easily hosted. Okay, you don't have to create the API yourselves. Okay. Okay, so we are almost done. Okay, perfect. Confirm your model's deployment by the following command. When it's done, we will see if our model is deployed or not. Okay, so as we will be seeing in the last section, we went throughout history. We went from implementing things, and then we've went into configuring things to the what we call configuration over implementation. That means that what you need to do is only configure things and you're good to go, instead of re-implementing stuff. And then lastly, we've went to configuration over convention over configuration, which is just a way of having some conventions, and then you don't need to reconfigure things. Okay, so here in the last section, we will see the configuration part. We will just be doing some configurations, and our API will be online. Okay, we just don't need to implement our API. So, okay, this might take a few minutes. Let's jump up real quick in the last section. We repeat the same I'd say pipeline, the same steps for preprocessing the columns, etc. So yeah, and here we have defined some variables that we will be using for the API next, for configuring the API next. Okay, so here we have the endpoint of our API that is being created here using endpoint, etc. This is the same here. We will be setting up a client options, which comes from the google.api core.client options, import client options, and we will specify some configuration here. The API endpoint is the defined endpoint here. The service, Google client.discovery.build, we will be using the version 1. Okay, and we need to specify the client options here that we've defined here, this object, to be able to specify the endpoint. Okay, and we will be using the version 1 of our model. Okay, so the name here and the version is the project ID, model name that we've defined here, that are the same as our environment variables, and then we're good to go. Okay, due to the size of data, it needs to be split in two. It's fine. The data is so big, so we need to do that in batches. It's completely fine. So yeah, we split it into two halves. The complete result is empty at first. For data in first half, comma second half, responses equal service dot projects dot predict. This is the service, and the projects is our model, is our let's say our pipeline, not our model only, not the classifier only. It's the pipeline. Dot predict, we need to predict. Here we specify the model name, the .joblib file, and the body of the JSON that is sent to the endpoint here. The body is instances. We have the data. Okay. Let me check with you real quick. Where did we define the data? Here in the for loop. Okay. In the features. Dot execute. It's only a method that is relative to the to the object returned by .predict. We need to execute that. If there is error in the responses here, we need to print that error to be able to log it. And if not, we just need to complete result that extend responses of predictions. We just need to append, I'd say, the predictions. But the difference between extend and append, extend if you need to append a list to another list. Extend appends only the items from the first list into the second. Okay, so here we have it, and here we are printing everything. The output should be like that. Okay, so because the data, the test set is so big, so we have split it into two halves, two batches of testing subsamples, and this is the big code here. Our endpoint is still being created. It's fine, we'll work for it, we'll wait for it. And I think we will be done. What else should I talk about? Okay, just a quick mention, guys. I don't know if you can see my email here. Please do reach me out if you have any questions, and I'll try my best to reach out as soon as possible. I would like to thank you for your attention, and yes, that's it. Let's complete the lab. This might take a few minutes. I'm sorry I've took this lab, but it didn't take so much time. Okay, I have 18 minutes left, but I can okay, I can just go ahead and okay, so let's wait some couple of seconds. If the version wasn't created, I'll just pause the recording and skip to the part where it was created. I just need another 20 to be able to finish this lab. And as I mentioned before, I'll try to include a video where I tell you how you can have this monthly subscription on QuickLab, in case you didn't know, and I'll include as well some some tips and tricks about data science stuff, and some quick tutorial about random forest. But yeah, I have some minute to talk about random forest. They've said XGBoost they will be using. I didn't see it, but it's somehow similar to random forest. So if you know the decision tree classifier that extracts some features and then try to ask some questions and then break down the dataset in a way that it can arrive to a certain point where it can decide whether it is this class or the other. So random forest, you can think of it as an ensemble or as a multiple decision trees. Okay, as the name suggests, random forest is decision trees. Each tree in that forest checks, I'd say, for a certain type of features, a certain configuration of features and questions, I'd say, and then try to break it down and classify each input of the dataset. And then what ensemble models do is just vote about which class is more likely to be the good class. It's of course on the training level, so that on the testing level we will have a high accuracy. Okay, great. So it's done. Okay, so they needed us to check. Okay, we needed to check if it's created. Perfect. The state is ready. Version 1. Perfect. Now we need to set up our test set and we're good to go. We went through all this file. The same thing is applied. nanotest.py, test.py. Okay, and then just run python test.py. So we will see our predictions here, the output. Okay, some of them, and there we go. I think it's still checking whether the come on, check for progress. Okay, I think there's something with Quick Labs today. I can check for my progress, but since okay, it's fine. But since I've completed this lab before, it's fine. But please be aware, do not end this lab before completing your points, because in case the lab has quota limit, you won't be able to restart it. All in all, again, I would like to thank you for your attention, and please do reach out to me via email in case you needed to brainstorm on something outside Scikit-learn and Google Cloud, etc. For example, TensorFlow. I'm a machine learning professional practitioner, and I am TensorFlow certified. So if you need anything, please do reach me out. Thank you and have a good night. Let's end this lab. Submit. And okay, so my account here will be suspended, so it won't make sense that I don't quit it.